Hi guys, my name is Nonkazi Mulonzoza and I'll be taking you through exercise 7.7 on page 135. It reads as follows. In an experiment conducted to see whether electrical pricing policies can affect consumer behavior, 10 homeowners in Johannesburg had to pay a premium for power use during peak hours. They were offered lower off-peak rates. For each home, the July on-peak usage in kilowatt hours last year was compared to the July usage 2 years ago. Do the data indicate a reduction in on-peak usage? Use alpha is equal to 0,025. And so when you read this question, the first thing that gives you a clue on what they're asking is, do the electrical pricing policies affect consumer behavior? And then they also tell you that 10 homeowners in Johannesburg had to pay for the premium for power usage during peak hours. And then they were offered lower off-peak rates. So they're using the same homeowners. So the consumer behavior is dependent on the off-peak rates that they got. And so you can start by stating your hypothesis, which is step 1. So H naught. And so you can let's call the 2 years ago mu D1 and last year mu D2. So mu D1 is equal to mu D2. And then your alternative hypothesis, mu D1 greater than mu D2. And I state this because if it's greater, then there was a reduction in the on-peak usage if 2 years ago is greater than last year. And so then your test statistics, since it's dependent, is T is equal to D bar minus UD at the null hypothesis over SD divided by N squared. And so it's one-sided, so we reject H naught if T observed is greater than, and remember this follows a Tn minus 1 distribution. So it's greater than Tn minus 1, which is actually T9 because there's 10 homeowners at 0.025, and that is actually equal to 2.262 if you go to your table at the back, your T table, which is table number 3. And so then for number 4.
Sorry, Nangane.
Yes?
So for step 1, when you're thinking of dependent samples, right?
Mm-hmm.
Always think of them like as two samples that were joined together.
Yes.
Right? So in your step 1, you never talk about two means.
Okay.
So you talk about one mu D, where mu D means it's the mean of the difference in the sample. So there's only one mu D.
Okay.
Right? So it's best there in step 1 to write mu D is equal to 0. And then
Mu D is not equal to 0.
Your signs were correct.
Oh, my sign was correct.
Yeah. Mu D is what?
Greater than 0.
There we go.
Okay.
Where mu D is what you understood it to be, which is the difference in the means. But
Okay.
we never write both means
Because they join together. All right.
In the case where they aren't joined together,
Yeah.
and you do what she did,
Yes. So when
That's
they're
wrong.
not,
So if it wasn't
not joined together, what kind of samples do we have?
we have
Independent.
Independent.
Yeah.
Then what she had was correct for independent.
Okay, because I think in my tutorial I was marked wrong for that,
For what?
for having what she had, but it was
Independent.
independent samples, but I had written it the way she did.
Okay. Did you have a mu D even there?
No, it wasn't a mu D. It was like mu1 is greater than mu2.
That should be fine. We can talk about that. Yeah, but it should be. So if you are dealing with a difference in two samples that are dependent, you call them mu D.
And then
Yeah.
the other one is delta. Is it?
The other one?
Is delta. Delta naught.
Delta naught is the difference between the two, right? It's whatever you have said in the hypothesis. So in our case, our mu D would be 0 because at the null hypothesis we said mu D is equal to 0.
Okay, so my question is,
Yeah.
there, you see what she's written on the right hand side?
Yeah. Yeah.
I can also say that delta naught is equal to 0.
Yes, definitely.
So both are correct.
No, you can't write delta naught in your hypothesis.
It has to be the mu.
Yeah, you have to specify what means you're talking about. Your delta naught is just whatever you have hypothesized, and that's what you're substituting in your T observed.
I think I'll have to come with my tutorial.
Oh, okay, that's fine. That's fine. Joran, that's fine the way you've written them now, but can you just,
I want to
avoid
specify.
confusion, can you get rid of the D? Because the D implies that
On
on
the
the
right.
right hand side. On the right hand, yeah.
Like, Liana, Renzo would like to show that it's a common mistake and stuff.
No, I get, no, I think ufuna ukubonisa ba you
Yeah.
have written it ngola hlobo
Oh,
for something else. But now, if you're talking about independent samples, the D only applies for dependent
For
samples, and
dependent
you're saying you're
samples.
combined them
Okay.
together.
Alright.
Delta naught no equal mu
To the power 0, yes, yeah. But here in dependent, we don't call it delta naught, we call it mu D at the null hypothesis. Because remember, delta naught assumes that you're talking about a difference in two means that are independent, right? But here they're dependent, so you're thinking about it as just one mean, but we're just calling it mu D. It's just one mean that came from two samples that are dependent. Does that make sense?
Can I start again and tell them not to do this thing that I did?
Oh,
okay
okay.
la
But this was a nice discussion.
Oh, so you guys get to see, ne?
those of matter calculation
Yeah, from your
Yeah.
DI
then that
values.
delta naught yena uzoba ngu-0
Mu D at the null hypothesis, yes, it will be 0 because it's the mean that she has hypothesized. That's the mean that she has put at the null hypothesis. Yeah, just wait for her to get to the other steps. No,
Mhm.
you're on the right track.
Okay,
Yeah.
I'm just gonna make sure that I clear this out.
Okay.
So guys, with your hypothesis for dependent samples, there is only one mean because remember, we're talking about the means combined. So you can't necessarily say what I did in the beginning with mu D1 is equal to mu D2 because we're working with one mean. So that will only be in independent samples. And even in the independent samples, you wouldn't say mu D1 because we're not working with dependent samples anymore. So I just wanted to clear that off. But otherwise, let's see, which means we're on the right track.
Is this
So-
going to be edited?
No. Okay, so mu D is equal to 0 and mu D is greater than 0. Because remember, we're working with one mean and with dependent samples, we've combined the two. And so, right, your test statistic, D bar minus mu D at the null hypothesis over SD divided by the square root of n, following Tn minus 1 degrees of freedom. And then, because we're working with a greater than sign, we reject H naught if T observed is greater than Tn minus 1, which is T9 and 0,025, which is the alpha we were given in the question. And then when you go to your T table, you'll find that T9 and 0,025 is 2.262. And so then to calculate your observed value, first, what you're gonna do is that you're gonna subtract from, okay, let me get my book, page 135. You get your DI values here, and these you're gonna have to get by yourself given the data that you've been given. So 2 years ago and last year. So what I did was said 2 years ago minus last year to get your DI values. And so when you subtract 2 years ago from last year, so we're saying last year subtracted from this, so 200 minus 160, which would be in the first one, the second one 180 minus 175, and so forth and so forth. And so the values you get from there is 40, 5, 30, 55, 10, 35, 50, 130, 35, and 39. And then you're going to input this on your calculator by, okay, it depends on the kind of calculator you have, but mine is you just press mode and you choose stat and you choose, I think it's number 1. And then you input your X values and then you get your D bar value, which will actually, on your calculator, it will say X bar. But since we're working with the DI values, you will state that it's D bar. It will be written as X bar in your calculator though, which is 42.9. And then SD is going to be written as SX on your calculator. But that's the standard deviation of your DI values. It's going to equal to 34.346, which is your new standard deviation from the new sample that you've calculated. Then I'm going to carry on with the observed value over here. Say T is equal to 42.9 minus 0 divided by 34.346 divided by the square root of 10, which is equal to 3.9498, which is the same thing as 3.95. Now for your p-value, we always note that for the t-table, the p-value is always between two probabilities. And so here you will see that at t9, you won't find this value over here, which means you must go to your extended table. And on your extended table, you'll find that your p-value, okay, first let's write this. T is greater than 3.95. And remember, because your t-table works with greater than values, this is ready for you to go to your table. And so then on your extended t-table at t9, you'll find that, remember, your smaller probability on your left and your bigger probability on your right. You will find that your p-value is actually be in between 0.015, so then p-value less than 0.0020. And so then that was your step number 5, getting your p-value. And so your step number 6, we have noted here that your t observed, what was your t observed? It's 3.95, is actually greater than your Tn minus 1 at T9 degrees of freedom. So your T observed is greater than Tn minus 1, and your p-value is actually less than alpha, because we were given alpha to be 0.025. And so, since T observed is greater than T9, 0.025, which was equal to 2.262, and your p-value is less than alpha. Alpha was 0.025. Your p-value is greater than 0.015, but less than 0.0020, which means it's still less than 0.025. And so then we reject H naught. We reject H naught and conclude that there is sufficient evidence. Okay, we can actually state that, not conclude. And state that there's sufficient evidence to conclude that the electrical pricing policies affect consumer behavior. Consumer behavior at the 2.5 level of significance. And there we go.
I've got a question.
Oh, okay.
So, how did you decide on, you see on your alternative, ne? Your alternative hypothesis.
Yes.
How did you decide on the sign of your alternative? What influenced your decision? And also, in addition to that, does it matter whether someone does 2 years ago minus last year and vice versa? And if they do vice versa, does that influence H1?
Okay, so if you do it vice versa, you're still going to get the same answer at the end, right?
Yeah.
But I said mu D is greater than 0 because if the mean of your new mean is greater, that means there was a reduction in the peak usage. And if it's less than 0,
Correct.
then there was no reduction in the usage of the electricity. And that's how we decided that mu D was greater than 0. But also with calculating your DI values, if you subtracted,
Yeah,
if you said last year minus 2 years ago,
yeah.
you'd find that all your numbers here are going to be negative.
Meaning what about your H1?
Meaning your H1.
You should be saying what in your H1 if you did vice versa.
So if you did vice versa, your H1 should have been
Less than.
less than.
That's important.
All
And
right.
people always get that wrong.
Okay, so if you said last year minus 2 years ago, your H1 is actually supposed to be mu D
Yeah.
is less than 0.
Correct.
And then you'll find that you reject
Yes.
H0 if T observed is less than negative
Yes.
2.262. And then you'll find that
Your T observed will
your
be
T
negative.
observed is actually going to be
Negative.
negative as well.
Yeah.
And you'll find that your T is going to be less than negative 3.95. And then you'll change your sign
And
to
get
T
the
is greater
same
than 3.95.
p-values.
But you're going to get the same p-value at the end. Yeah. Okay.